Hey everybody, the purpose of this video is to get you some solutions to this t-test quiz. It's actually a matched pair quiz. You're testing to see if student scores on a reading speed and comprehension assessment went up significantly after some kind of an intervention of some kind. So anyway, we're trying to see if we are increased from before to after. Now, a quick glance at the data looks like up 2, up 4, up 1, down 2, and then up 7. So there are more ups than downs, and the ups weight-wise are larger than the downs. But then we have to check for statistical significance, not just mathematical significance. This is a good candidate for a matched pair t-test because you've got each student, and then you've got a before and after, which means you are able to subtract the before from the after. When you have that kind of tie of each student, a matched pair is a really good way to go. And a really good way of thinking about it is each student was measured twice, right? Each student was measured twice, as opposed to two different students each being measured once. You've got each student being measured twice. Let's get this thing started. Okay, oops. Where did my Word document go? There it is. So we're going to test an average, and that average is going to be average difference between the before and after scores. All right, there we go. Let's get a space there. All right, and you can set this up to be either greater than or less than 0 as far as the average goes. It depends on what you subtract from what. If you subtract larger numbers from smaller numbers, this would be negative. But I'm choosing to subtract smaller numbers from larger numbers, which means I can set the null to less than or equal to. All right. We'll mention that again when we crunch the data. Okay, your two types of error. Pretty straightforward. A false positive would be saying the scores have increased when they actually haven't. How many of those did I spell right? A couple of them. Actually haven't. Okay, that's a false positive. The false negative would be saying the scores haven't increased when they actually have. Yeah, your choice on which one's worse. Your choice completely on which one of these is worse. I leave it up to you. I can see reasons for both. Distribution will be a T because we are talking about 2 or fewer averages. Test statistic and the p-value come from technology. I'm going to run the TI here. Got the data ready to go. Remember, on the TI or also in Excel, we're going to subtract the lists. Now here's where I go back to my null hypothesis for a moment. If I want the average to be greater than 0, that means I think the numbers in L2 are bigger than the numbers in L1, right? L2 bigger than L1. If that's the case, I want to subtract L1 from L2, second L2 minus second L1, which will give me predominantly positive numbers. And that's what we're going to check, is we're going to actually see, oops, there we go. And we're actually going to see that. Test it, and then stat tests, t-test. We have data. It is in L3. We are testing against an average of 0 for sure. And we're going to see if we are greater than. We're going to go ahead and draw it because I think you guys like that. All right. Okay, it's not significant. We got a test statistic of about 1.17 with a p-value of about 15%. So your T is going to be about 1.17 standard deviations, which again, we knew that's above 0, but it's not significantly above 0, which is indicated by the big p-value of about 15%. There we go. Let's make that red. So it does not appear that scores have increased after the intervention. All right, and we could be wrong. We could be wrong with a type 2 error because it's a negative test result. But more importantly, it shows promise, and it probably deserves to be looked at with a larger data set. You shouldn't just throw this out and say it's done and not publish it and not talk about it. Say, you know, you got positive, you got a positive t value here, right? That means something interesting may have happened. It might just be goofy randomness, sure, but something cool might have just happened in there. It's worth replicating, because if you were to run this data again, remember, run it again with more data and get similar results here, here, back in the data, similar results here, then just by virtue of the central limit theorem, you're going to get a more extreme t-test statistic, which would drive this p-value down. So again, null results, in my opinion, are important too. I hope I'm not the only one that thinks so. Anyway, hope you guys found this helpful, and we'll catch you in class.